In this video we're going to look at how we can use the fact that some events are independent to help us solve probability problems. And one thing that it's useful to know about independent events is that the probability that one event happens multiplied by the probability of another event happens is equal to the probability of both of those events happening if they are independent. And this can be written as the probability of A intersection B equals the probability of A multiplied by the probability of B. And we're going to use that to help us construct a Venn diagram, which is then going to be used for working out these probabilities that we're interested in. So the probability of A is 0.1, the probability of B is 0.6. So the probability of A and B both happening is equal to the probability of one happening multiplied by the probability of the other happening, which in this case gives us 0.06. So I now have enough information to construct a Venn diagram. So I've got my events A and B, and we've just calculated the probability they both happen is 0.06. So that's this central bit here. So the probability that A happens we knew was 0.1, so that means that this probability must be 0.04, so then that A ring adds up to 0.1, and I can take a similar approach over here to show that this must be 0.54, so then that ring adds up to 0.6, so these together add up to 0.64, which means that this must be 0.36, so that the whole box is going to add up to the probability of 1. So now I'm going to try and work out these various probabilities. So the first thing I'm looking at is the probability of A union B. So this is the probability that something is either in A or in B. So region by region, this region is not in A or B. This region is in A, so we can use that. That's in A and B, so we can use that. And this one's in B, so we can use that. So it's these three probabilities which is going to add to 0.64. So next one, this is the probability of A given not B. So we know it's not in B, so we can ignore those two because we know it's not there. And I want to know the probability of A, so this is the only bit that's in A, so it's going to be a 0.04, so I'm just going to do that here so I've got a bit more space, so it's 0.04 divided by my new total, which is 0.04 and 0.36, so that ends up being 0.04 over 0.4, so that gives me a 0.1. So the probability of it being in A, given that we know it's not in B, is 0.1. So next one, the probability that it's not in A, given that it's not in B. So it's very similar to what we've just done before. So we know it's not in B, so we cover that up, but this time we want to know it's not in A. So this is going to be 0.36 over 0.04 add 0.36, and that's 0.9. And then the final bit, the probability that it's in A and the probability that it's not in B. So the probability is in A or it's not in B because we've got this union, then that's going to be checked one by one. So can we include this? Yep, because that's not in B. Can we include this? Yep, because that's in A. Can we include this? We can, because that's in A. Can we include this? Well, it's not in A and it's in B, so no, we can't include that. So if I add these three probabilities together, I've got here 0.46.